Hello, welcome to the Copter Who submission for the PA Pie competition. For this year's competition, we have chosen to build a quadcopter that is able to transport small payloads. The main payload that we have chosen is for COVID use, which will work by carrying vaccines and testing kits into areas that have been contaminated, therefore ensuring that more people are not put at risk. The idea behind this is that health companies such as the NHS can buy a fleet of drones and use our app to send COVID vaccines or tests to the location. This will help us to develop a clean-up world as well as support the health industry by providing them low-cost help. Finally, it will allow us to get urgent supplies into the hands of those who need them the most.
This is the app for our project. As you can see, it has a map showing you where you are right now, and we can use this little menu to either access settings, add a drone, or set the route of a drone. First, since we have no drones at the moment, we will need to add one. So here you can see we'll type in the name of the drone, which can be test drone. And now we can pair it with the nearest drone. That's done. And now we will add the drone. And as you can see, the drone is now on the map where it currently is. Also, you'll see down here that the sender details and the receiver details are also there with a distance that should be there, but none of them are there at the moment. This is because we haven't set a route. So we'll go to the menu again and we'll go set a route. Type in the name of the drone that you just made so that it accesses the right drone. Drone_test. That's test. And now I'll have to type in the sender, receiver, and distance. Okay, now I've typed all the details in, and we're now going to set the route. And this will make the drone start flying, so stay out of the way.
The drone uses a pair of cameras connected to a camera scheduler to avoid objects. The algorithm works out the depth of objects on the screen by comparing two different images, one taken from a left camera and the other taken from the right camera. First, the cameras are calibrated so that the images taken will be aligned perfectly when an error correction algorithm is applied to them. This is necessary as the two cameras will not be identical in reality. A disparity map is then formed from the two images using a block matching algorithm, in which the screen is split up into different blocks, and each pixel in each block is compared to find out where the differences are. This disparity map is then converted into a 2D map of the environment by projecting the disparity map onto a plane, and then choosing the closest point at each location and mapping that onto a 2D plane. The drone will move by adjusting the speed of the motors using a feedback loop program. To yaw, each pair of clockwise or anti-clockwise motors will change speed to produce a torque on the drone and cause it to change where it is facing. To adjust pitch or roll, motors on the correct side are increased in speed to produce a torque on the drone. A gyroscope is used to carefully manage this process to make sure the drone does not lose control.